Hey there, science explorers! Today, we're going on an exciting adventure to discover the amazing world of heat conductors. I'm your friendly guide, Professor, and I am here to help you understand which materials are good at conducting heat and which ones are UNT. So, grab your lab coats and let's dive in. Imagine you're in a magical kitchen where everything comes to life. We have some curious utensils, eager to show us their heat-conducting powers. First up is our shiny friend, metal spoon. Watch as metal spoon bravely dips into a steaming pot of soup. Look how quickly its handle heats up. That's because metals like steel, aluminum, and copper are excellent heat conductors. They allow heat to travel through them super fast. But wait! Here comes Wooden Spoon, waddling over to join the experiment. Wooden Spoon hops into the hot soup too, but something different happens. Its handle stays cool. That's right, wood is a poor conductor of heat. It doesn't let heat pass through easily, which is why we often use wooden spoons for cooking. Now, let's meet Plastic Fork. This colorful character decides to take a dip in the soup as well. Just like Wooden Spoon, Plastic Fork's handle doesn't get hot. Plastics are also bad conductors of heat, which is why many kitchen tools have plastic handles to keep our hands safe. But what about things that aren't in the kitchen? Let's take a trip outside! Here we see concrete sidewalk and grass patch having a heated debate. On a sunny day, concrete sidewalk gets super hot because it conducts heat. Well, but grass patch stays cool and comfy because it's a poor heat conductor. That's why it feels nice to walk barefoot on grass on a hot summer day. Back in our lab, we have two more friends to meet. Glass beaker and rubber glove. Glass beaker is a bit of a show-off, conducting heat pretty well, but not as quickly as our metal friends. Rubber glove, on the other hand, is proud to be a bad conductor, keeping hands safe from heat in many situations. Now, let's play a fun game. I'll show you some objects, and you shout out whether you think they're good or bad heat conductors. Ready? Here we go! First up, a silver necklace. Is it a good or bad conductor? If you said good, you're right. Metals like silver conduct heat very well. Next, a fluffy wool sweater. Good or bad conductor? That's right! It's a bad conductor! Wool keeps us warm by trapping heat, not by conducting it. How about a brick? This one's tricky. Bricks are actually moderate conductors. They can absorb and release heat, but not as quickly as metals. Last one, a styrofoam cup. Good or bad conductor? You got it! Bad conductor. That's why styrofoam cups keep our hot cocoa warm for longer. Great job, everyone. You're becoming heat conductor expert! Remember, good conductors like metals quickly transfer heat, while bad conductors like wood, plastic, and rubber help keep heat from moving around too fast. Before we wrap up, here is a cool experiment you can try at home with your parents' help. Get 3 spoons. 1 metal, 1 wooden, and 1 plastic. Put them in a bowl of hot water. Not too hot for a minute. Then carefully touch the handles. Which one feels hottest? Which one stays cool? Now you can see heat conduction in action. I hope you had as much fun learning about heat conductors as I did, teaching you. There's so much more to discover in the world of science. If you want to join me on more exciting adventures, don't forget to hit that subscribe button below. Until next time, this is Professor Thermo signing off. Stay curious, young scientists.